In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a great, to a fool. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tone trumpet prongs. Burning, breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Bills. Joe, what's up, man?
Hey, what's up, everybody? Yeah, I was doing the intro hand motions there. Man, explaining this stuff gets intense sometimes. It'd be throwing hands like a drunk guinea on a Sunday, you know?
Yeah, it gets pretty bad, man. It gets worse every time you start doing it too, because then I find it and look for it and just.
That's it, man. That's it.
All right, Joe, is everything magnetism? That's the topic, man. So let me just set it up for you. We watched a little bit of Ashton, and he had someone on from NASA saying that everything was magnetism. So let me just ask you the question: is it?
Like everything else we discussed, that's not such a simple answer. Briefly, no, not everything is magnetism, but everything does have to do with magnetism. And magnetism is a part of it, and it's what I would consider to be a multi-layered function of electromagnetism as a whole. So there's elements of magnetism and polarity that exist at all levels, whether you're talking about the atomic level, all the way up through particles, all the way up through molecules into the macro world, and then way beyond. This is something that we see over and over again, is this attractive and repulsive force. And but again, it's my belief from the very beginning that being that electromagnetism only has manifest effects, so to speak, in the presence of matter, and it really depends on the ratios of energy and matter in a given area that depends on the electromagnetic mode, so to speak, that is present. That magnetism is really only a part of it at that point, based on that logic.
Okay. So does everything hold a charge then?
Yeah, another loaded question, isn't it? Kind of. Not necessarily hold the charge, but being that everything is in motion and that everything is a disturbance of the still in a cumulative form that exists, there has to be some type of energetic property to even the most inert of matter. And therefore, even at the molecular level, by virtue of that motion, I would say that that motion would, if not a charge, at least a polarity.
Well, can it have charge without the polarity, though?
Can you have charge without the polarity? I mean, well, you could have a separation, but just because you have a separation of a charge or a separation of a polarity through like a filter, or like how you deal with hot energy and cold energy, and they exist on two sides of the coin, you can have one without the other. But just because you have one doesn't mean that the other doesn't exist. And doesn't exist, and does exist in proportion to the amount that exists of the other side of the coin.
Okay, so
it's an inverse thing, you know. If you have one on this side, it's one on that side.
Does a electric have a charge on it? I mean, that has a pole to it?
Well, it's, I wish I knew more about electrets than I do, because I always feel like I understand them, but at the same time, kind of putting it into words becomes a little bit difficult for me, just because I haven't talked about them enough with people that know. So I could very well stand to be corrected. But does an electret have a charge? I'm going to say it does, and that charge is an accumulation of the um, the different composites that exist within an electret itself. So you have a certain structure to the electret with aggregates and other types of materials in there that lead to different interactive oscillations, and those interactive oscillations are charge forming. They're able to actually build a charge based on their etheric impact. I guess that's the way I'll put it. Etheric impact.
Well, we know they have a charge. I guess what I'm asking you is, Joe, does it have a north or south pole? Does it have a dipole? What's in an electric?
So that's a good question. So I don't know exactly, but what I would presume is that the materials contained within the electret are going to be both positive and negative. Okay, now what they jostle out as far as the static accumulations, I mean, I would suppose that would probably be on the negative energy spectrum of things in a static form until they're broken loose from the electret material itself.
Okay, I asked because if you look at it in some ways, a magnet is simply how do I say this? An amperage field that is stuck exactly where it is, placed at a moment in time, and does not change until it loses the ability to hold the charge. So an electret would be the opposite. So it would be pure electricity holding a charge, right, in a suspended state.
Yeah, so, I mean, more or less, I mean, an electret would be like an equivalent of a piezoelectric under a continuous pressure strain. So it's always, pulling a voltage out of either its structure or the ether around it, or both. And again, then it's just a matter of being able to discharge and capture that charge for it to become usable for that process to continue again. Because like anything else, it's going to have a maximum amount that it could build up.
So you think a piezoelectric disc would have electric properties, not magnetic?
Well, I mean, it kind of depends. Technically, it could kind of have both, but if you're just talking about a piezo disc into itself, it's probably more similar to an electret than it is, forming any form of magnetism. But at the same token, they don't work, like the mechanism in which they utilize to work those similar is not the same. Because the piezo depends on a pressure to create the voltage, whereas the electret is kind of on auto run with that same process based on its constituent materials.
So let's say it this way. An electret, a piezo is more like, and it's just my words, a radiant field than anything that we use. And I'll say it this way. It pushes an electric field really fast, really good, and you see it spike on your oscilloscope. It does push a magnetic field because you're going to be able to pick it up on your speaker, you know what I mean, as it hits. So the sound comes through. So you know that it's going to have both. So here's the thing. When you get to a Tesla coil that oscillates the, oh my God, I can't think of the word right now. It oscillates both fields, right? Why can't I think of that word?
It oscillates both fields, you're saying?
The transverse and longitudinal field.
Oh, okay.
So you get a magnetic and a static field that it oscillates between. The piezo is pulling the same thing. It's oscillating between both of those. I call that new field that it makes a radiant field. So if
Okay.
I say a piezo, I would say it's a radiant field. So then I would look at like anything crystal form that we get it to activate. I would say that that has to be in a radiant form. Being that they're built in radiation is where these things are made and how they're constructed. It would make sense that the lower form of radiation, which would be radiant, would be possible to excite them. So that's where I come off on it. What's your take? Is that good?
Well, I
bad,
mean,
indifferent?
I'm actually on board with what you're saying, but just to kind of go that extra degree, we're considering the piezo to be an energy discharge, but you have to remember what it is at its root form. Its root form is a frequency oscillation, and that frequency oscillation is realistically scalar until it's not. So it does collapse, and that's how you end up with the transverse wave out of it, where you get both. But in its regular form, all you're getting is a pure oscillation, which is measurable. And then it becomes analogous to a measurable current.
The reason I ask and the reason I state it that way is because of lab tests. I'll explain the test, and I've explained it many times. To move a static field, you need a radiant field. Okay? To play with the magnetic field, inside there, you need a radiant field. When you can do this, you can apply both fields and make plasma.
Okay. Sorry. Before we go further, I want to backtrack slightly because Limited said something important to address before we really move on. So we said that if it's transverse, it's not radiant energy, period. Okay. Now
that's wrong.
I'm gonna
wrong.
I'm gonna play both sides of the field here, where you tend to be right and wrong a little bit, and him too, in my opinion. Okay. It is transverse, okay, until there is an electromagnetic mode discharge. Okay. So until that oscillative energy, the oscillation, the frequency, is measured or used through a conductor as a voltage, it is radiant energy. Okay. It is scalar at that point. Okay. So if you apply pressure to a piece of quartz, okay, and it doesn't discharge a spark, it's still creating energy, it's still outputting energy, whether it's measurable as a volt or not. Now, this tends to be like an observer effect to a degree, because it's one until it's the other, and it's the act of there being a conductor there, matter in the presence of the radiant field. If you get what I'm putting down here, how I said at the beginning, magnetism is a part of it, blah, 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 right? That's when it makes the change over to a transverse wave. Okay, so it is both.
So hold on. But you have to understand how things are built. I'm putting the magnetic field in, right? So it's transverse, okay? I'm getting the result, okay, which is the effect, which is the longitudinal, right?
Mm-hmm.
But as soon as both are done discharging inside of that, I get an impulse, okay? Goes in, hits here, impulses. The impulse blows out the radiant field, okay? That's what's going on here. So it's technically right that if it's just transverse, it's not radiant. But once you use the transverse field to make a longitudinal field, then the impulse transforms it into a radiant field.
I get what you're saying in the context of where you're putting it. You know, if you're just thinking about just a quartz crystal and that's it, then and nothing else, okay? Then or a piezo disc and nothing else, right? Then it tends to be a little bit different. But in the context that you're saying, I don't disagree.
No, I'm saying it that's the way that it works.
Yeah, no, that's definitely the way you're saying is
not just a piezo.
In that context.
It's working the same way in my Tesla coil. Here's the thing. Let me just say this. I know what he's trying to say. Here's the problem with it. He's trying to illustrate the fact that it's got to come out and be a static field out of the number 2 coil. Okay? The problem is it's not. If it was static, the first thing that would happen to you is you'd be the sock in the dryer. You come out and everything clings to your clothes because you're discharging thousands of volts of static electricity into the air, right?
Is that magnetism?
No, it's not.
Does it act like magnetism? I'm just trying to bring up the topic that we're discussing in context of what you're saying.
No, because this is what people aren't understanding. As it goes between one field to the next, it changes the fields together in oscillation. As you resonate both fields together, it changes it. That's the problem. It no longer stays a static field. Matter of fact, you won't have any static value on you whatsoever.
You're right. I mean, I understand that because at that point you've taken an accumulation of static energy, more or less, and you've added flow pattern to it. And now, again, tying it right back into things that we discussed very recently, those flow patterns and their relationship to, matter and such in the vicinity of that flow pattern is going to determine the mode of how it manifests. Once what you're saying with the radiant energy occurs, once the static is put into motion, it's depending on what that flow pattern is as to what you get out. If it's spiralytic, then it's magnetic. So
this is the whole crux of the issue, though. If you can't see that third field is formed, you'll never build the fields around the Earth.
Yeah.
Ever. You'll never understand crystal energy and stuff like that.
Nope.
It just won't happen. That's the blind spot right there. As soon as you do that and you say static is coming out of it and have zero static value, you've lost everybody, because then, dude, I should be able to stick myself to everything. I should have fuzzy balls running across the room sticking to me. You know what I mean? It doesn't happen that way. It just doesn't. If I touch it, my hair should go way up, right? No, I don't. I get shocked. It doesn't work that way. It's the compression that's changing it too. You are compressing a static field. You're not just discharging it. You're compressing it. You see, you start looking at Wormhurst. Wormhurst is simply shooting it out. It is not compressing in any way possible. It is simply building and discharging, building and discharging. Okay? You go to one of those static electricity machines, right? All it's doing, building and discharging, building and discharging. In this case, you're compressing it. Once you compress it, you've changed that energy. That's the problem. So let me get back to the piezo, and the reason I think it is, and remember I tell you it moves things, right? It's exactly what the piezo is doing. So think about it. You're pulsing in cold energy, something without a high magnetic field. When you do that, it amplifies the electricity in there, because the resonance itself inside the coil is adding a value to it, right? Or it's multiplying the value in it. That's what's happening. So it makes sense, but it does not amplify the magnetic field to it, but slightly, which makes sense if the way you build it. You know what I mean? So that's why I want to say it that way. I 100% believe magnetism is part of everything, but it may be a building block in everything, or it may be the abnormality that we look at and exemplify as the biggest thing, but it doesn't have to be present in every part of it.
Right. Yeah, that's a good point. I mean, I actually learned something interesting that I kind of want to share. I mean, it's somewhat relevant. And I only learned it recently. It was about solvents. And I saw this video on what determines like what's soluble in what, right? And what I never knew, but it made total sense, is it has to do with charge.
Okay.
So if, like, for instance, if you try to get an oil stain out with water or something water-based, it just doesn't work. You'll always have like that oily, greasy residue stain. It doesn't come out of the fabric, etc. Right? But that's because the oil is negatively charged and the water is positively charged.
I didn't know that.
And you need a solvent with a negative charge in order to remove the oil, which is why you would use gasoline or kerosene or rubbing alcohol or naphtha or some kind of dry cleaning agent. I forget what they call that.
Paint thinner for that?
Or something, paint thinner. Sure. Any like, so you have spirit solvents, and then you have water solvents, really, water-based solvents for the most part. And there's others too, but those are the two main ones, right? And it all has to do with charge of what you're trying to remove.
Did not realize they had charge in them.
And I didn't know that up until very recently, but think about it from that magnetic perspective again, right? Opposites attract. But yet, when you're talking about a solvent, it's the inverse. The likes attract, they accumulate, they pull it out of the fabric when it's a like charge. And that's the same as it is when you're talking about self-organizing structure, when you're talking about accumulation of different charges. It's the same, just across the board. So these things work on the macroscopic level as well, and it's directly relevant to what you're saying about any sort of static and what ends up happening with the static. It's because it's the accumulation and self-organization of the static energy, so to speak, that allows you to then use other fields, other forces to then redisperse that into something usable. The same with the solvent situation.
Yeah. Dude, I'm blown away. That's pretty cool. Well, hold on. If they have a charge to them, are they like a weak charge? Is that?
I mean, it's a molecular charge. It's the same as ionization, except ionization isn't always just a positive or negative or whatever. I mean, it could be either.
Well, I'm just curious. Like they take a rag and they charge a pipe and it has charge on it. You move a can with it. Can you do the same if you have a solvent like that? That's why I'm asking if it's weak, heavy. What's the level of it? So maybe somebody can do a test and they can see it.
Something to think about, something to experiment with. But that also raises the question: is can you get a stain out of fabric, knowing what its solubility is, just by applying an ionic charge to it?
Oh, I don't care. I don't do the laundry.
Well, listen, if you want to solve a dry cleaning problem and become very, very wealthy, maybe you want to think about that one. Then then you can build some Tesla coils. You know what I mean? Like, don't blow off my good ideas, bro.
No more work. How about we go to the other end of it? The off gas that comes off of it, would it be positive or negative based on the charge of the solvent?
I would assume that the vapor of the solvent would probably, mirror that of the original solution.
That's funny, man. Because do gases even hold a charge? I don't deal with gases a lot. So do they hold a charge?
Well, they could certainly be excited, can't they? Right? We see that all the time. You wave around your fluorescent bulb and the thing lights the hell up. What do you think it's doing in that moment? That's the thing is, a lot of these phenomena that we experience, right, with it, like lighting the fluorescent light bulb, because it's electromagnetic in nature. Okay, there's no solidification of the organizational structure, so to speak, of the energy in those systems, like a crystal, right? So that's to bring it back to the other day. So crystals are permanent, like a magnet, like a neodymium magnet is permanent, right? It just by virtue of being locked into those attributes has the given effect, right? These are all simulated. Okay, so when you're dealing with radiant energy, you're creating an unlocked in version of the same. So, once you take away your energy source, then your light goes out. The excitation then over time would dissipate and eventually lose its, I want to say lose its charge, but it would lose its inductive charge that created the level of excitement in the first place. Now, whether or not it still had a charge in the first place, I mean, I would assume that everything has some type of polarity bias. That's what I'll call it, a polarity bias.
Okay, so this stuff acts like when you have it in your test, right? It acts like it pulled the static out of the coil, right? It took it away, but it also took away the magnetism. So it took that too. But the field is everywhere. Like this stuff it just continues to grow. And the more you compress it, the more it grows. So that's what I'm saying. It feels so different in person than you would think it was. Because you would think, oh my God, you're discharging that. There must be stuff all over the place. No, not really. If there's no discharge coming out, you get like no action, but then the field itself shoots everywhere. Like things start to get hot in the room, all the metal gets hot, and it's everywhere, but it has no static value and it has no magnetic value whatsoever. But I'll say this, if you compress it and then put heat into it, what happens is it takes that entire thing and flips it just like that. Just instantly, boom, right into a magnetic charge. It'll just boom, right into regular voltage. It takes 1 second to do it or less, and it will flip on you. So that's what I think happens when they apply, like, your feet to the ground down the hall with the socks and things. You're flipping a field. You don't realize it, but that right there, what you're doing is flipping the field. When you drop a magnet off of a high building and they're compressed together with the same pole together, it creates friction in there. And that friction changes and it's flipping a field. So now that flip is what changes the locality that it's going down in to slow it. Because now it's reacting with that energy in the radiant field. It can't flip the whole thing. It ain't got enough power. The world is too big. But in that certain spot, it'll flip it. That's why when I tell you a UFO always needs a bubble, it's 100% right, because you have to flip it in the locality that you're in order to do it, because you can't make enough energy to flip it against the world.
Okay, so you're making a couple of good points there. So to kind of boil that down into something, that knowing the components involved, charge, polarity, temperature, rotation, geometry, symmetry, etc. Right? All these different factors that go into these fields, the field geometries. Okay. The key to having it be successful, is to have a separation of the sides of the coin, right? So positive, negative, north, south, hot, cold, you get the point, et cetera, et cetera. Once you have these separations, now you have your yin yang. All right. Now, anytime that you're starting to build an accumulation and under compression of one side of the spectrum over the other, just like anything that, is outweighed on one side more than the other, it's going to try and correct itself. Because almost everything in the universe is self-correcting in some way, shape, or form. Once you throw something out of equilibrium, it tries to correct itself. All right. So that is the mechanism of the field flip at that point, is because you built up one side heavier than the other, so to speak. So it's got to kind of dump and switch in order to regain the equilibrium.
That's propulsion. As soon as it flips and it tries to correct itself, it becomes propulsion. That exact moment. That's why you have to
because now and that makes sense, because that introduces a new axis of motion.
Yes, there you go.
Okay, so it would be like a fifth or sixth axis of motion at that point. Yep. Which is, again, and I've said all along, It's all upper dimensionally when you start getting the crazier effects, okay? Those upper dimensional axes, once you start moving those wheels, it starts to, like a gear, pull on the lower dimensional forces by orders of magnitude, okay? So once you start pulling those upper dimensional axes, you know, which really is dependent on just adding additional axes of movement and rotation, which, you know, it becomes exceedingly hard to kind of fathom what that motion may look like, but it is tangible. And I wish I kind of would have drew it ahead of time. But if you imagine a gyroscope, right, and the gyroscope suspended by like a hook arm that then rotates, but then that hook arm's hooked up to another hook arm that also rotates. And now you have all of these rotating forces, and then you just ignore those arms attached to it, right? And all you do is follow with your head and your eyes the motion of the sphere in the middle. What you're going to notice is that it's a very purposeful motion, repeating pattern, okay, that seems to be all over the place because you have all these different axes that don't make any sense in our traditional way of seeing things, but are omnipresent in the environment that we see.
Sure.
Now, if you could center the ball, so to speak, in this thought experiment that I'm proposing, right? That motion would actually create the effects in themselves, just the motion alone, without any sort of input. Because the more axes that you move, the, you know, things start to get screwy with how, you know, space-time surrounding it is flowing, because it's no longer moving in conjunction with that. It's moving on more axes than it.
Yeah, but motion alone can't do it. You have to have a field to the motion.
I don't know.
Well, okay. I can't take a wagon wheel and get it to spin 7,000 RPM and get it to change something and lift. You know what I mean? I need some kind of force with it. You know what I mean? Because there's force being applied to it. So there has to be something that changes that in order to get this to move.
No,
So I don't
it's just
disagree with
important
the
to remember
motion.
that anytime you're putting off these fields in general, and you're getting the saturation in a room and it's building layers and all this stuff, those layers are experiencing the exact motions, okay, that I'm describing. It's just not tangible.
No, I agree with the motion, but then you just said right there that those fields. So I'm just trying to say the motion has to have a field of some sort.
Okay.
That was it. That was my only thing. It cannot be by itself. Wood by itself has no field.
Well, I mean, I'll tell you what, if you were to build a massive, probably highly dangerous ride because of the amount of G-forces, right, where you were just in the middle of this gyroscope. Now, they used to have the gyroscopes that used to strap yourself in and then you go around on at least 2 axes, but let's say you jack that up to 6 axes with different spin arms of increasing size, and you were still in the middle of that ball, okay, I would beg to differ that you know, as the person in this that's centric of that upper dimensional motion, that there wouldn't be some type of objective difference. You know, like I think that it would.
Oh,
Whether or not there's a field.
yeah, but okay.
I mean, it's speculative. Listen, I don't know. It's just a thought experiment, but
Putting a field has a reaction in any area to be able to create a field based on the field that we live in. Okay, so if you create heat in any way, you're doing it. Rotation and massive speeds can create heat in one way or the other, or it can create cooling in one way or the other. But it's still activating some part of a field to push against you, or you know what I mean, away from you. So there has to be some form of energy in it. Now, how you transform that energy is on you. Yes, we see Brandon. He's having a good time. So
yeah, we got a lot of good people out in the chat today, as always. Thank you, guys.
Here's the thing. I describe things in a certain way, in a certain pattern, so that everybody gets why things are going to work right when you do them that way. Because right now, look, I know you're reading, but I'm trying to get a point across. They continue to say everything's magnetism because they're not learning one step comes before the other.
I agree.
They have no idea how to build it. Because they don't know how to build it, we get in the situation where they just regurgitate stupid information. Does that make any sense to you?
I mean, you kind of put me in a hard spot because what you're saying makes sense, but I don't necessarily agree with it at the functional level. There's a lot of validity to, especially like the resources at hand that were utilized to make that point in the first place. Like there was a good amount of validity to it. I think that it's very clickbaity to kind of say everything is magnetism. I mean, I think, and this is something I said to you just before we came on, I really think that if you want to say something is everything, something is actually like, if something was everything, like those orbs are everything, because of how their polarity is and how they organize. And that's something important to realize about charge, right? So if something's negatively charged, that doesn't mean that it only has a negative charge. And I agree with this. Does it make sense? Okay. That just means that it has an offset bias on the interactive perimeter of it that is a negative charge. But there is a positive element to it.
Oh, yeah.
And geometrically, from a three-dimensional perspective, that would be inside of the negative charge. Why? Well, because they have magnetic components of attraction and repulsion and self-organize. And it's that exact geometry that would allow for something to be attracted to and come together, but not so much to smash into each other and blow into oblivion or form a more complex molecule or anything like that. Instead, it's attracted, accumulates, and then locks sort of into place. And then when the next one comes, it falls right into that other place, just like the orbs, did. So I think that everything is more analogous to that, and that is actually a precursor to magnetism. That's my opinion. That's all a precursor to magnetism anyway.
You're making my point for me, Joe.
Yeah. Well, I mean, I'm not here to argue with you. We usually agree.
Yeah. It's not that. It's even in an electric, there's still magnetism in an electric. Okay? There is still an electric field in a magnet. So the problem is if you don't know what two fields are building, you won't realize that part is in every single field, right? So if you have three elements and you say, okay, the part that we're not considering is the radiant value of any field. A magnet has a radiant field. How do we know? Because it builds out from it. As soon as you spin it really fast, it builds out more, right? It's that field that's building out. You're not building out the magnetism, you're building out the field. In an electric field, in an electric, you're not doing that. It still has a radiant value to it. You see, it's each one you're amplifying in the three. So when I tell you that, it means that there's an A, B, and C field, and you have to put every single one of them in there.
Yeah.
That's why people don't see the radiant field, because they don't put it in the beginning. They're never calculating for it. So then when we get to it, they don't understand it. It defies their laws of everything they wrote down, because very little magnetism, very little static value, but it has the huge, radiant field to it, right?
Yeah, yeah.
But then we make a magnet and we say, okay, it's still there. We make an electric, it's still there.
All right, so I was gonna disagree with you, but then you saved that pretty early on for me disagreeing with you, which I'm glad, because I was like, it really can't be radiant with magnetic properties because they just don't. That just doesn't jive, but it kind of does. Like at the end of the day, remember, it goes back to the episode on scalar that we did and what scalar is. And when you think about the energy flows, it's just like little arrows, okay, on a piece of paper, okay, and your flow pattern, okay, your vector of propagation, so to speak, all right, is deterministic on the type of manifest energy mode that you're going to experience generally. Okay, we fundamentally agreed with that, and whenever whenever we're talking about radiant energies, inward or outward flow, okay, not, in a minimally diffuse state, almost a laminar state, so to speak.
Mhm.
That's not going to be magnetic. Now, there could be elements of that field as it breaks down into turbulence through interference that then have magnetic or excited moments. If the flow of the inward outward vector propagation becomes spiralitic in nature. So if it turns into a vortex at some point in time, that vortex will immediately collapse into a toroidal flow pattern, and that toroidal flow pattern will have magnetic property. Yeah.
Yes, it will.
Mhm.
I've seen that. Well, I think that's what I'm trying to say. There's more than two fields that you're playing with. And I know what Steinman said. Okay. And I know he said there's two fields, but I'm telling you there's a third. And that's one of the problems we're having here. Is they're not accounting for it. When you build something, you have to. If you see something in your lab and it comes out as an anomaly, you can't just ignore it. It's not one of those things you can give a zero value to. I mean, anything that you have a field for, if you name it a zero, you failed, dude. Just take your physics diploma and go wipe your butt with it and throw it away. Because that's about what it's worth.
Well, that's what John Bigman was just saying in the chat too. He was saying, yeah, but Joe, no matter how hard you try, you're always going to have a magnetic component to it. It's part of the backflow. So that's actually perfect. I agree, and that's case in point. Is that it's in that case it's a mechanism of the backflow, which then makes it a secondary component, not a primary component. So when you're talking about but for, okay, that is but for that backflow that then collapses into toroidal magnetic properties from so it's a component of, but it's not a building block, it's a result. That's the point. So it's sort of like saying, I built a skyscraper out of Legos, so all Legos are skyscrapers. No, not all Legos are skyscrapers, but you could use Legos to build a skyscraper. Yes. That's sort of what it is, right? And that's why it can't be everything, is because it is a manifest byproduct. It is a secondary or tertiary function.
So you would have to have two functions together to make it, or three to make that field. Is that what you're saying?
Right. I mean, it's like you experienced when you were dealing with the spacing on primary coils, where you would have arcing, then you would have a plasmatic discharge, and then you would have a magnetic discharge. And then if you got it perfectly arranged, magnetic field would suck in on its side. And, that's when you have the highest power input. It's because the magnetism is still there, but the toroidal flow pattern has become so tight that it becomes longitudinal in a way. So in that case, it becomes confusing because it's on so many levels, and I mean that. It's like, like toroids just inherently exist, and toroidal flow patterns are inherently magnetic in their nature. And how they manifest in their magnetic properties is largely deterministic. If they're traditionally polar, or if they're like, I don't want to say monopole because it's not, but you get what I'm saying. Like where it has a charge bias in one direction or the other, like I described before.
Yes. Well, you see, this is why I do the experiments in forward and then in reverse, right? if I can use a Tesla coil to turn on a light bulb, right? Can I use that same energy I'd use to turn on a light bulb to turn on a Tesla coil? And the answer is yes. See, that's the thing. If you do them back and forth, you could find out what the fields are actually doing. That's
Yep.
a lot of people don't do that. They just do the one, hey, it worked, it was great, it's outstanding, but I don't like it that way. I want to know what it's actually doing, how you're making it, what parts are there,
Right.
and things like that. So, you know, it's kind of hard because now when you get to matter, was there magnetism to build the matter? See, because I think there was, but then matter itself displays no magnetic properties. But then in some instances, it can. So
yeah, and this is where it like, and I think like this is where like particle science kind of, you know, if it proved anything, it kind of proves this. When you go up in scale and down in scale, it's just omnipresent, fractal and repeating. So when you say, well, and then there's no magnetic field in this, right? If you go down to the constituents of the oscillatory effects or static charge or whatever it is, okay, that is making up that field, okay, at that point in time, those themselves are magnetic in their ideology. See what I mean? So, no, macroscopically, no effect. When you break it down to the pieces, every single piece of it has a magnetic function. But then you go into them, and then they don't have a magnetic function until they do again. You just keep on zooming in and in and in, and it's just you could lose your hair trying to think about it because it just goes like that. That's how it goes.
So here's the thing that gets me. What happens if you, through a coil, put light in and it creates mass?
Run that by me one more time. I'm sorry.
If you took a coil that was strong enough and you put light through it and it created mass, okay, hypothetical, right? What then? Because you know that there's magnetism in the light. No matter what you do, magnetism had to be part of it to create the light. Then it goes through and it creates mass, but you say mass has no magnetic value, right? But then
I didn't say that, but okay.
Well, we're in the hypothetical. So then you go, okay. Now it comes to a fundamental question. Did you lose it or did you just drop it down to a microscopic scale? That's kind of the thing here.
Right.
So that's why they talk about states of matter and things like that. So it's kind of odd, but a rock in itself probably has everything in there. And we don't realize it because the amount of it has to be so minuscule. Right. In order to have just mass by itself, or not by itself, but you know what I mean? The majority of it, the 99% or however you want to say it.
Right. Yeah, it's a lot to think about, man. I don't know that I have it off the, I mean, it's somewhat rhetorical, but I don't really have a response to that. You know, you can make mass out of light, though. It's been known for a very long time that if you slam it with enough gamma, it'll start to accumulate mass. So you can make matter out of light. Now, I mean, if your coil's powerful enough to be emitting, you know, high power gamma radiation, and, you know, you put some coherent light source in, you probably start to get some good accumulation, I would assume. But it probably doesn't even have to be that strong if all the resonance values are in check. And that's where it comes in, because the amplification at that point, in my opinion, would happen at the microscopic level. Okay, so you would have these intense reactions on a very, very, very small level that would really probably lead to, like kind of like Bernie does, like a monoatomic discharge accumulation. But it all has to do with resonance at that point. And, you know, the light would have, the wavelengths of the light would have to be, you know, properly in tune with everything else that's going on in your field. That's proper densities.
We have examples of lightning hitting rocks, and when they do, and you keep that rock in the same place, so like you hit a boulder with it, and they have ancient time stories, and we can go out to see them today. You could go over to the rock and hit it, and it rings like a bell. It pings, ping, ping, just like that, right? You go over to the rock next to it and hit it with your hammer, right? Thud, Dud, dud. So what happened is all the electricity went through it. Okay, the light went through it, and it rearranged the molecules inside that rock. Okay, so that it has to be connected in that vortex line that it created in that rock. Okay, in order to change the value of the sound.
Mm.
Now, if you move the rock from where it sits, it will no longer make that pinging sound. It no longer has the same value because it's drilled into not just that, but all the way down to the next rock. So, in order to do that, you must have a magnetic value inside that rock. You must have an electrical value inside that rock. You get what I'm saying to you?
Well, right. I mean, you're gonna find values wherever you look for them if you go close enough in. That's kind of that's what the spectrum is made of. Like our entire reality spectrum is made of just all variations of these different electromagnetic interferences, basically in different states of compression. While you were saying that, I literally hallucinated something that like kind of made me go, "Oh no!" And I like whether or not I want to mention this, I don't really know. But if you take your coil, okay, and then put your two plates together, and you get your laser, and then you reflect that laser back through where it came.
I don't know if I like this at all. Go ahead.
I'm pretty sure that's your matter beam.
Plasmoid?
That's your matter? No, that's your matter beam, man. That's your phaser. Because you have full resonant coherence and then inversing onto itself, recharging and so it's basically creating a laser, then creating matter out of the high coherent light that's in full-blown resonance with the system because it was created thereof, and then recharges and creates matter and then blasts off with it. I'm pretty sure that's how that might work.
Okay. Oh my God. So, all right, we're not hallucinating. Okay, I got one for you then. What if it's literally this? It has to form this. It has to cross. It can't go like this. Okay. Not two dudes where it has to cross. Okay. And I'll say it like this, because as soon as you go like this and cross it in some way, they spin. And as soon as they spin, they can accumulate more. And the more energy accumulates in that ball, then it can create the matter. So it has to cross in some way or have a.
That's if you want to keep the matter. If you wanted to blast the matter off into something using wild amounts of kinetic energy, well, then you don't want that rotational force in that case as much. You want to be able to produce it, blast it in, have it do its thing as it's doing the pass through, and then out it goes.
Well, see, okay. Sometimes you want two different fields that look like they're the same field. You need one that shows the laser, okay, that shows the light, but the second field you don't want seen at all. You want that to just go over there and change something on molecular level as soon as it hits it, right? But you need the two hitting together in order to make the result. So sometimes you want different. And then if you put them together, you can get pressure. And in those pressures, it'll come out just like we talked about with the piezo. Boom, 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 boom. That's what that coil inside of a coil inside of a coil, that was part of what that experiment was.
Well, and right in line with that would be, and what's the best way to say this? You know the star in a jar, right?
Okay.
And then you know what Merkaba was trying to do. But technically speaking, if you get your toroidal patterns and your null zone correct, and you have it where you have a secondary toroidal flow inside that actually gains energy through the eddy currents that would be, I wish I could draw it. Think of a toroid inside of a toroid, and then the flow patterns and the torsion that would occur in the internal structure of the second torus, the internal torus. right? You'd have the same exact null zone, but you would have all these eddy currents that stir up additional torsion and energy, creating a higher density shield, so to speak, around it. And if you could technically get light into that situation and everything's in pure resonance, it would act as a simulated star in a jar. It would have a sustained atmospheric cavitation effect that would occur, because you would have hemispherical and polar toroidal flow motions times 2 that would then allow for that sort of compression to potentially take place. Once you have light caught up into that high energy field, provided that it's still taking in atmospheric energy, and because at that point, if you've gotten to this point, you've broken locality, by the way. So now you have to still concern yourself with how much atmosphere is coming in. Now you have atmosphere coming in, and that could also lead to matter accumulation as well under that particular circumstance. Which is the same thing as you've been saying about the layer, same sort of deal. But I think that's one thing we've never really touched on is the the intertoroidal the intertoroidal torsion and eddy currents that actually churn up and amplify. So I think that that's something that we haven't really said, but is definitely present.
So check this out, Joe. I'm going to say this, and I just need you to understand it the way that it heads in my mind, right?
Yep.
Okay. I'm taking my original field, I'm taking my transversal and my longitudinal field and my Tesla coil, and I'm creating my radiant energy for a reason. Now I know I need to push that in order to get force, right? So I know I'm creating this, right? But I'm creating it in order to speak to the field that's already going around us, right? Now I want to get that mixed in and heavily mixed with the atmosphere itself, right? But now I want to flip it and then pulse it as fast as I possibly can. So now okay. I need some sort of magnetic field to interact with that, right? At the point where it exits out of that tube, okay? Say if I did my original one, then I have another one around it. I need that point to flip, and then I need that piezo to hit it, okay? Because I want to create propulsion out of it.
Yeah. Well, I mean, that makes total sense.
I guess in the question, if everything is magnetism, in small parts, everything, I guess, is. I mean, you can make a real legitimate argument that everything has it in it, but is it all like magnetism, like they would say it and state in one of those questions? No. Like, is everything...
It's chicken or the egg. Because, yes, is it more or less omnipresent at different scales? Absolutely.
Yeah.
Is it the smallest piece? The answer to that for me is always going to be no. But at the same exact time, what does it really matter? It's just an ever-present attribute of things that we, that find in our reality, really.
I wanted to thank everybody for watching today. If you like this kind of content, we do a live show every Monday, Wednesday, and Friday right here on YouTube, 2 p.m. Pacific Standard Time on the main channel. The link will be in the description. Please join us, get in the chat, and have some fun. With all that said, hit the music.
The old man Bill. The old man Bill. The old man builds, the old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. caveman